Okay, so this is question 7, and this type of question is always going to be one of the harder questions for most students in the exam and obviously in the test that you did. Thinking through multiple steps to do some sort of transformation isn't easy, but it is possible for you to get these sorts of questions right if you just think of you just have to think a little bit more laterally, and you have to just think about starting to analyze this sort of question. A lot of you had actually done that, and you'd started to get the sort of the thought process right, but unfortunately your what I can only really say is your sort of lack of understanding of the individual reactions meant that you weren't getting to where you needed to go. So as an example, if you look at something like this, the way you want to break this down is you want to realize that well, we've added one extra carbon. I mean, we've added this where this OH is. And to do something like that, to change an OH into something else, means that we will have had to have changed this OH into a leaving group. There is only the examples where we change an OH into a leaving group and make it into water and then put something else on. The only examples that are practical for you are to use something like HBr to change the OH into a better leaving group, something that is more usual for nucleophilic substitutions. And so this is the first sort of step that you should have been getting to. Now, doing this means that you're already thinking in terms of the way that you've learned your work, in terms of all the reactions and the reagents and everything. You understand this sort of principle. So you've got to know your work very well. Know it well, and you'll be able to deal with something like this. Also, this sort of question, don't be confused. There's like sort of looks like two arrows over there. This doesn't mean it takes place in two steps. Don't be confused by this. The question says that it's a multi-step synthesis. What I can assure you of is that we would never ask you a question that required you to do more than something like 4 steps. I mean, even 4 steps is a bit of a tough one. 2 steps, on the other hand, is actually a little bit too easy. So yeah, I'll leave it up to your imagination of what the normal number of steps is, but please don't take that as you know, an answer of how many to expect. You've got to think a bit more laterally, and you've got to think about all the different options. So making an OH into a good leaving group is a possibility. We do not have any reagent that can make this go and do a substitution reaction over there. To do that, all right, if it were possible, would be to have like a COOH, but like a minus on the carbon over there. And we don't have anything like that. Why? Because a minus on a carbon is going to eat up the H that we have over there, because that's an acidic H, and so we'd actually just end up with the formate group, which is not a nucleophile, well, not in the way that we want it to be. So the trick here was to notice that in the product we've got one extra carbon. If we are ever adding one extra carbon, it is more than likely coming from the cyanide anion, CN. And so if we use sodium cyanide, right, we can do our nucleophilic substitution. We get the CN, and then going from CN to the COOH requires an acid hydrolysis. All right. This, as I said, is a question I can just show you. I can show you the answer. You're probably looking at it now like, oh, that's how it worked. Again, this sort of question is a type of question in the exam that you want to leave for a little bit later on, where you've got some time to sit and think about it. Go work through the paper, work through the questions which you're more confident with, that are a lot easier to do, and then come back to this one and sit and think about all the things. This is where we are testing your ability to think logically and to be thinking further than just one step at a time. All right. Good luck.